problems in doing case control study design. And by no means am I using this to criticize the investigator. He knew he had this problem. Nevertheless, we wrote the paper up as a teaching example. And of all the papers I was ever involved in that was sent off to publication, this was the one that was accepted the quickest. I remember the editors wrote back to the investigator, this fellow, and said, "This is a great study done by people who know what they're doing." And it wasn't a great study in that the results were valid. It was a great study that we knew we had biases. We tried to use that as a teaching example. So here was the study design. We were looking at risk factors for developing aortic stenosis. So let me leave that for a second and just talk about what aortic stenosis is. I get most of my knowledge off of the web, and you probably do the same thing. If you searched on aortic stenosis on Google, for example, you'll get a number of websites to connect to. This is the Wikipedia website. It says aortic valve stenosis. So we're talking about one of the valves in our hearts. Aortic stenosis is a valvular heart disease caused by incomplete opening of the aortic valve. Basically, most of you guys know a lot more about this than I do. We all know that the heart is made up of 4 chambers, 2 on the left, 2 on the right. The ones on the right take in blood that's being circulating from your body, and it's for the purpose of pumping it into your lungs to pick up a fresh supply of oxygen, which are then pumped into the left-hand side of your heart, the 2 chambers there, and then ultimately it's pumped back into the body. So on the right-hand side, we have the one chamber known as the right atrium, another one known as the right ventricle. Blood comes into the right atrium from your body that's needs to be enriched with oxygen, pumps it through a valve into the right ventricle, which then pumps it through the lungs, picks up oxygen, and then returns that oxygenated blood into your left side of your heart, into the left atrium, which then pumps it into the left ventricle, and then pumps it through the aortic valve into a large artery that leads it to the rest of the body. So we're talking about this particular valve here, the aortic valve. We're talking about a diseased valve in that particular chamber or valve connecting your heart to the large artery that brings blood into your body. So let me go back to Wikipedia now. So aortic stenosis, the aortic valve controls the direction of the blood flow from the left atrium into the aorta. The aorta is that large artery that the aortic valve does not impede the flow of blood between these 2 spaces. But under certain conditions, in other words, when the valve itself becomes narrowed or constricted, what happens is blood has a tough time being pumped out of your heart, out of your left chambers of your heart into this aorta, and as a result, your heart starts building up blood pressure, and you can ultimately develop congestive heart failure. So this particular problem caused by faulty valves is known as aortic stenosis. And just to go back, what my colleague wanted to do was to identify what causes aortic stenosis. So he was doing another study at the time. He was looking at people who were undergoing cardiac catheterization. Cardiac catheterization occurs when someone puts a catheter, a long tube, into your body, winds it into your heart to measure certain chambers of your heart. And what he had were 105 people who were known to have aortic stenosis. Those were his cases. He wanted to know whether such things like smoking or diabetes or congestive heart failure could cause this condition, aortic stenosis. So what he did was a case control study where he enrolled 3 groups of controls. He had another 110 people who underwent cardiac catheterization and did not have aortic stenosis. But these were people who we knew, based on the gold standard, the cardiac catheterization, these people did not have the disease, aortic stenosis, but the 105 cases they had. But from the cardiac catheterization, we knew they had other problems with their hearts. All 110 had another type of valvular disease. One of the other valves connecting the chambers of their heart, the mitral valve or the tricuspid valve, was malfunctioning. So these were people who didn't have aortic stenosis but had another type of valvular heart disease. That's what we mean as control group number 1. Control group number 2 were another group of 170 people who underwent cardiac catheterization, didn't have aortic stenosis, didn't have any type of heart disease, and had no problems with any of their other valves. So these were 170 healthy individuals as far as their heart was concerned, particularly as far as their valves were concerned. And then finally, we had a third group, 269 people in control group number 3, who underwent a surgical procedure at the Brigham and Women's Hospital, my hospital where I work. And that procedure was not expected to be caused by any of the risk factors of interest for us. So it wasn't a disease or a problem that was caused by hypertension or cholesterol or smoking or diabetes or a family history of heart disease. This group was selected by my colleague for this particular study. The first two groups, 110 people in group 1, 170 people in group 2, were previously collected as part of the bigger study he was doing. He knew they had problems with those two studies, those two control groups. He didn't want to use them in his study as appropriate controls to compare to his 105 cases of aortic stenosis. And therefore, he went out and collected a new control group, 269 people. So as I've described this, what I'd like you to think about is, are any of these three control groups in your mind appropriate controls for this case control study? We have 105 cases of aortic stenosis. We're going to be asking them, did they smoke in the past? Were they hypertensive in the past? Were they high cholesterols in the past? Were they diabetics? What we want to know is the amount of smoking or diabetes or hypertension among them larger than what would be expected? So what we want to know is how much hypertension or smoking or diabetes existed in the source population that these cases of aortic stenosis came from. We'd like to have somehow a baseline amount of smoking, hypertension, cholesterol compared to that of the cases. That's what we want these controls to be. And in your mind, are any of these three groups, control group 1, control group 2, or control group 3, appropriate to compare to those cases? In particular, right now, we're talking about a selection bias. And to give you the answer, my colleague was concerned about group 1 and about group 2 as being inappropriate because of potential of a selection bias. And I'll explain that to you in a minute as we go and show you a couple more slides. Now, just to complete the picture, this was a zero budget study. This was done totally on the energy of this one cardiology fellow. He reviewed all medical records. Nobody was interviewed. We didn't ask anybody, cases or controls, about their smoking, their diabetes, their hypertension. All that information was obtained by him reading the medical records of those people. If a medical record showed no mention of a risk factor, then we assumed that that risk factor was absent. Meaning if I opened up a medical record and they said this person was a smoker, we'd classify that person as a smoker. If it said this person was a non-smoker, we'd classify him or her as a non-smoker. If it said nothing about smoking whatsoever in the medical record, then we would classify that as a non-smoker. Now that's a big assumption. That assumes that the question, are you a smoker, was asked to that person when this information was being gathered. And it assumes that that person answered the question as probably saying no, because we assumed that if the answer was yes, the record would have recorded that. And we're assuming if the answer was no, the record would have recorded that. Or if we assume the answer was no, we assume that the record was left blank. So no information is the same as answering no to the question about you being a smoker. And that's going to bring up another type of bias we're talking about in a minute, misclassification bias. So let's go on and show you what happened in this study. My colleague didn't like control group number 1 as a control group. He was afraid that what causes aortic stenosis might also cause other types of valvular heart disease. And therefore, when I compare the smokers among my cases of aortic stenosis to the amount of smoking in control group 1, I might find no difference in the amount of smoking because maybe smoking is causing both diseases. And therefore, that tells me control group number 1 is not an appropriate control group because their amount of exposure history might not be typical for the population at risk, they might be overestimating that amount of smoking because smoking caused their